vibrations of an atom to define 1 second. Every atom naturally vibrates at an incredibly fast speed. If electromagnetic waves of that particular frequency reach the atom, it absorbs that energy and resonates, increasing its energy level. This is the natural resonance frequency of the atom. The frequency for a given atom never changes. Thus, they can serve as an exceptionally accurate sort of pendulum for marking the passing of time. Katori's optical lattice clock design takes advantage of this principle. The atoms are inside this futuristic-looking device. The glowing blue is strontium atoms. Strontium atoms were understood to vibrate extremely fast, allowing for a more precise definition of 1 second. But their exact natural resonance frequency was unknown. Measuring the exact vibration frequency of strontium so it could be used as a time reference would require cooling the atoms to near stillness and a way to trap them in place for measurement. Katori took inspiration from a commonplace trap design. An egg carton. He wanted to keep the strontium atoms firmly in place, like the eggs. He devised a way to trap the atoms with an egg carton-shaped lattice. It can hold 1 million strontium atoms at once. The shape is created with laser beams. The laser beams have a fixed wavelength. When reflected back with a mirror, the waves reinforce each other in some places and cancel out in others, creating a regular grid pattern. Nearby strontium atoms are trapped in the bowls of reinforced light. The egg carton-like design succeeded in holding the atoms in a lattice shape created with light. Hence the moniker optical lattice clock. The strontium atoms used in the optical lattice clock were found to vibrate 429,228,4,229,873 times per second. It's the latest thing in atomic clocks. One day, it may provide a time standard used throughout the world.
You know, when someone mentions Einstein's general relativity, we tend to think, oh, this conversation might get too complicated. But in the Skytree experiment, the optical lattice clocks actually showed us how relativity is part of our lives. It will be interesting to see what else these clocks can be used for. Our guest today has been solid-state battery developer Dr. Ryoji Kanno from the Tokyo Institute of Technology. Dr. Kanno, what are your closing thoughts on the science and technology we saw today?
研究を進めるにあたって諦めないということが大変重要だなというように私は感じています。混沌としたところからどこにいいものがあるかという探し出していくターゲットがどこにあるかというわからないところから、見つけ出していくという非常に時間のかかる、ありで実はここが本当は面白いともう少し この固体電池の実用化に向けて我々も頑張っていきたいというように思っています。
Dr. Kanno, thank you very much for joining us today. ありがとうございました。
ありがとうございました。
And thank you viewers for watching our program. We'll see you next time on Science View.